All right. So multiplying real numbers. Basic rules. Okay. Now this is where it starts getting a little bit more difficult because you got to keep the rules obviously separate from our addition rules. Okay. Because they are a little bit different. Okay. So our basic rules are these. When you're multiplying two negatives, your answer is a positive. Okay? That's the biggest one that people have trouble with. Because when we're adding two negatives, obviously the answer is negative. Okay? But we're talking about multiplication. So when you're multiplying two negatives, your answer is always positive. Okay? When we're multiplying one negative, the answer is negative. And I'm having a hard time writing on my screen this morning. So, bear with me. All right. So, the answer is negative when we multiply one negative. Okay? So, by our rules, the associative property of multiplication says that you can only multiply two numbers at one time. Okay? Now, obviously, when you have three small numbers, you can do them very quickly, but you still are multiplying two numbers at one time. Okay? So that's why they only give you basically multiplying two negatives or multiplying one negative. Okay? Now, the other rule is this. There's not really another rule, but the add-on to this rule would be this. If there is an even number of negative signs, then the answer is positive. Okay? For example, if you were to have this right here, you had negative 3 times negative 10 times negative 2 times negative 4. Okay? In that problem, we have 1, 2, 3, 4 negative signs. Okay? It's all multiplication, and we have 4 negative signs. Okay? This is going to equal a positive. Okay? It just is. Okay? It doesn't matter what the numbers are. It doesn't matter which one's bigger. It doesn't matter which one's smaller. It has nothing to do with that. It simply has to do with, I have 4 negative signs. 4 negative signs is an even number of negative signs, so it's going to be positive. Now, the mathematical reason for that is this. If I take negative 3 times negative 10, well, our rule just said if I'm multiplying two negatives, I get a positive, and so that would be a positive 30. Okay? Now, if I take a positive 30 and multiply it times a negative 2, so 30 times negative 2, that is one negative sign, so that gives me negative 60. Okay? Now I take negative 60 and multiply it by negative 4. Negative 60 times negative 4 is two negatives multiplied together, which is 240. And so we have proved mathematically why an even number of positive negative signs will equal a positive. Okay? That is why that rule is true. Okay? Now, the other rule that coincides with that is if Okay? If I have an odd number of negative signs, then the answer is going to be negative. Okay? So I can take that same exact problem, -3 times -10 times, what was the next one? -2 times, and let's say I had that right there. Okay? Now, if I do it that way, I have 1, 2, 3 negative signs. 3 negative signs would be odd, and so that's going to equal a negative answer. Okay? And the bottom line is it would equal -240 when you multiply it out. Okay? Because your first two, these two here, give you a positive. So then I take that positive and multiply it times a negative, and that's going to give you a negative answer. And then I take this negative and multiply it by a positive, and that's going to give me the -240. Okay, Nick? Two times, yeah, you could do the 30 and then take 2 times 4, which would be 8, and 8 times that is 240 either way. Because that brings me back to our associative property. Our associative property says when you're multiplying more than 2 numbers, okay, when you're multiplying more than 2 numbers, it doesn't matter which 2 numbers you multiply together first or second, you're still going to come up with the same answer, okay? When we're talking about, now let's just look at those. Let's remind ourselves of these properties. Commutative property. Okay, since we're on this, let's just really quickly here. 2 times 4. 2 times 4 is equal to the same thing as 4 times 2. The commutative property says that you can take 2 numbers if you're multiplying them together and actually adding them together, but right today we're talking about multiplication. The commutative property says I can take 2 times 4 and 4 times 2. It's going to equal the same. 1,000,000 times 10 and 10 times 1,000,000 are going to be the same number. Okay? So the commutative property says I can take 2 terms that I'm multiplying, flip them, and I get the same answer. Okay? The associative property says this. If I'm multiplying -4 times -6 times 5. Okay? Well, it doesn't matter. The associative property says it doesn't matter if I do those 2 numbers first or if I did this. Doesn't matter if I do those 2 numbers first. Does not matter. Either way, I'm going to end up with the same answer. Okay? So let's just prove that. -4 times -6 would be a positive 24 times 5 would be 120. Okay? Now, it's positive because I have 2 negative signs. Okay? Now, over here, if I do this first, it's still not going to matter. That's -30. Okay? -30 times -4, and that's going to give me positive 120. Okay? So I just proved the associative property. Obviously, the associative property has already been proven, or it wouldn't be a property. Okay? So we didn't have to prove it. I've just shown you that it's true. Okay? Now, there's a couple other properties. Let's see here. The identity property. Okay? The identity property is real easy. Basically, if you multiply anything times 1, 1 times A is equal to A. You know, basically 1 times 4 is equal to 4. 1 times -4 is equal to -4. Okay? So basically, just saying, you know, you obviously We've talked about this property before. We talked about it in 6th grade, talked about it in 7th grade. So it should be, a review more so to you than anything. The next one is the property of zero. Okay? Basically, anytime I multiply 0 times a number, it's going to be equal to 0. Doesn't matter if I'm multiplying it times the positive or if I'm multiplying it times a negative. It's still 0. Remember, 0 is neither negative or positive. 0 is 0. Okay? So when you multiply something by 0, you don't ever come up with a negative 0. Okay? You don't come up with a positive 0. Okay? So this is one that the rule doesn't apply to. 0 times negative 5 is still 0. Well, you said that if we have one negative sign, it's negative. 0 is not negative or positive. Okay? So you just have to write 0, obviously. Now, the other property they talk about is the property of opposites. Okay? Okay, the property of opposites is basically this. If I take and multiply -1 times any number. Okay, if I take -1, okay, why is it not showing? There it is, okay, just a little behind. If I take -1 and multiply it times any number, I'm going to get the opposite of that number. So, for example, if I take -1 times -4, okay, well, what is the opposite of -4? 4. Okay, that's what -1 times -4 is. It's the positive of 4. Okay, and so just understand that anytime you take a -1 times any number, you're going to get the opposite of that number. Okay? Yes, Michael. Yep. All right, now, that brings me to having to plug in here because my battery is getting low. All right, now, that brings us to a couple of things I want to talk about before we move on to examples of some more examples. I want to talk about vertical displacement. Okay, now, vertical displacement is talking about downward or upward motion. Okay? Vertical displacement is talking about falling or jumping, you could say. Okay? But basically, displacement is the change in the position of an object. Okay? Okay, displacement is the change in the position of an object. Okay, unlike distance, in other words, when you travel distance, do we ever have a negative? In other words, did you travel a negative 2.2 miles? No. Distance can't be negative, or it can't be negative. It has to be positive. Okay? Displacement can be positive, can be negative, and it can be 0. Okay? So that is the difference between distance and what we're looking at. Now, for vertical displacement, okay, there's a formula. I'm going to call it V vertical displacement is equal to, okay, velocity times time. Okay? So vertical displacement is equal to velocity times time. Now, velocity can be negative or positive. Okay? If velocity is negative, okay, that means you're going in a downward motion. Okay? If velocity is positive, then that means you're going in a positive direction. Okay? So that's how you tell the difference between the two. All right, now, let's see if I know there's one in here. Let me find an example right quick. See if I can find one. Let me see if I can find one right quick. So there's an example in the book, but I'm trying not to do those. Let's see. All right, everybody look at the example in the book. Look at page 95, okay? Look at example 4. Okay? We have a picture of Matt Shelton at the top of page 95. We got the flying squirrel. Now, interesting fact here. Let's read the interesting fact. It says, real life, flying squirrels can't really fly as birds do, but they can glide through the air by using gliding membranes, flaps of loose skin that extend from the wrist to the ankles. Never ever seen a flying squirrel in real life. I'd like to. Okay. Now, it says in example 4, it says a flying squirrel descends from a tree with a velocity of negative 6 feet per second. Okay. Find its vertical displacement in 3.5 seconds. So, it says that the flying squirrel, that's really not a flying squirrel, but a gliding squirrel, okay, the flying squirrel descends, okay, obviously we got to know the difference between descend and ascend, okay. Obviously, when Christ ascended into heaven, okay, they were talking about vertical displacement. Okay, now obviously he didn't ascend at they didn't say he ascended at a certain, feet per second or anything, but that's the difference. Ascend and descend. Ascend is rising, descend is falling. Okay, so he descends at negative 6 feet